Alright, so this is a quick temporary video for organic chemistry, alkane nomenclature. This is a booklet of organic chemistry that we are working on. Question number 6 tells us to circle the parent chain in the molecules and identify the type of branches that are in each molecule. So let's begin in part A. We have a bond line formula. Each vertex in that diagram is a carbon atom. So that's a carbon atom at the end, this is a carbon atom, this is a carbon atom, etc. And they are bonded by just single bonds, which is why this is an alkane. So to begin with, we'll try to find the parent chain. It says circle, I'm going to highlight it. So the parent chain is the longest continuous chain of carbons. So one way to do that, and there may be more than one way, but one way to do that would be to start down here, carbon 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 carbons in a row. You could have done that in a different way. Someone else may have started over here and then said 1, 2, 3, 4, 5, 6, 7, 8. That would also be acceptable. So there's the parent chain. It's got 8 carbons. It would be an octane. Now the branches are these things that are coming off of the parent chain. So we have one here, 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 and here. All of those branches have just one carbon, and that means those are all methyl branches. In the second example, we have what's called a condensed molecular formula. First, try to identify the parent chain. A lot of students, when they first see these, want to call this the parent chain, but there's a mistake when they do that. The parent chain is the longest continuous chain, and although that is part of the parent chain, you have to also include this. If you start at the end down here, you can just go 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in a row. That would be the parent chain. So that the 9 carbons means this is a nonane or a nonane alkane. The branches are these things coming off. So we have a 1 carbon branch, and we also have a 2 carbon branch. The 1 carbon branches are methyl, and the 2 carbon branches are ethyl. All right, so I'll let you try the remaining examples there. Question 7 says give the name of the parent chains. So I kind of did that already, but in part A, the parent chain that was highlighted had 1, 2, 3, 4, 5, 6, 7, 8 carbons. So down here you'd say the parent chain was octane. In question 8, you need to write the full name, the UPAC name, as well as give the molecular formula for each of these branched alkanes. The molecular formula follows a general formula, CnH2n plus 2. So if you have N carbons, you'll have twice that plus 2 more hydrogen atoms. So let's we'll jump into a couple of these together. Part B, start by finding the parent chain, the longest continuous chain. So if I start here, carbon 1, 2, 3, 4, 5, 6. So there's 6 carbons. That's a hexane. And then we have these branches. The branches would be here and here. Those are both 1 carbon branches, so they're methyl branches. Now you have to tell me where in the hexane parent chain those branches are attached. So we put numbers on the carbons in the parent chain. And you're supposed to number from the end closest to the branches. In this molecule, it doesn't matter which end you number from. If you start from the left, this would be carbon 1, carbon 2, the first methyl branch is on carbon 3, and the next one's on carbon 4. If you were to count from the other direction, you would also end up with a methyl branch on carbon 3 and another one on carbon 4. So it doesn't matter which end you number from in this example. So we have 2 methyl branches. We'll put 3, 4 to tell me where they're found. We'll put a dash, and because there's 2 of them, we use the prefix di, dimethyl, 2 methyl branches. And then the parent chain again had 1, 2, 3, 4, 5, 6 carbons, so that is hexane, 3,4-dimethyl hexane. The formula, hexane has 6 carbons. The methyls have 1 carbon each, and there's 2 of them, so this would be C8, and then the number of hydrogens would be twice that, plus 2 more, so it'll be C8H18. We'll try one right underneath it. Start by finding the parent chain again. So the parent chain, the longest chain, 1, 2, 3, 4, and we can go either direction. I'll go down 5, 6. So again, it's a hexane molecule. And the branches, this time there's 2 different kinds of branches. There's this branch here which has 1 carbon in it. That's the methyl branch. And then there's this branch over here which has 2 carbons in it. That's the ethyl branch. When you're naming these things, you have to put the names alphabetically. So ethyl will come before methyl in the name. In terms of numbering, 1, 2, 3, 1, again, I don't think it really matters. If you number from the left, we get the methyl on carbon 3 and the ethyl on carbon 4. If you number from the other direction, you'll also have a 3 and a 4. So it doesn't matter which end you number it from, but there will be, in one case it'll be a 3-methyl, in the other case it'll be a 3-ethyl. Just either one of those would be acceptable. So putting the ethyl first, we get 4-ethyl and then 3-methyl. So the ethyl branch was on carbon 4 and the methyl branch is on carbon 3, and then hexane is the parent chain. And technically, methylhexane should be one word. Just like up above, dimethylhexane is all one word. All right, so there's a couple of examples. Let's try one more. No, we'll leave that. So I'll leave you to finish that off. We did part J in class together already. Question 10. Let's do part B. These are condensed molecular formulas. Can you find the parent chain in this example? So the parent chain, the longest continuous chain, will start up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 carbons in the parent chain, the longest continuous chain. And then in terms of branches, I see a methyl branch on this carbon, I see another methyl branch over here, and I see another methyl branch over here. And then we also have an ethyl branch, which is here. So we're going to name the ethyl branch before the methyl branches alphabetically. In terms of numbering the parent chain, if you start from the left side with this guy as carbon 1, then the first branch would be on carbon 5. And then on carbon 6, you have 2 branches. You have an ethyl and a methyl, so I'll put 2 6s. And then you'd have a 7, carbon 7 also has a branch. Now if you number from the other direction, so carbon 1 is on the right-hand side at the bottom, then the first branch would have been on carbon 4, and the next one would be on carbon 5, and another one on carbon 5, and then the other one on carbon 6. So you want a number from the end that keeps the numbers smallest. So in that situation, we're going to number the parent chain from the right-hand side because that'll keep the branch numbers smallest. All right, so let's go ahead and name this. We'll put the ethyl first. So the ethyl's on carbon 5. So this will be 5-ethyl. And then we have 3 methyl branches, and we should have to say where they all are. So the methyl branches on carbons 4, 5, 6. And then there's 3 of them, so we have to use the prefix trimethyl. Now just a reminder, when you're alphabetizing, you do not look at the prefix. You didn't put trimethyl after ethyl, you put methyl after ethyl. So be sure you're not including the prefix when you are alphabetizing. And then the parent chain had 10 carbons, so decane. The molecular formula for this, decane has 10 carbons, 3 methyls, so we're up to 13 carbons, and that 1 ethyl, that's 15 carbons total. And then the number of H's would be twice that, plus 2 more, so C15H32. Question 11 asks you to draw the bond line formula for some molecules. Why don't we try question, how about question B, 3,3-dimethyl octane. So start with the parent octane, and we're going to draw bond line formula, so those dashes. So 1 carbon, 2, 3, 4, 5, 6, 7, 8. There's 8 carbons in a zigzaggy pattern to reflect the tetrahedral bond angles, 109.5 degrees. Carbon 3 has a methyl branch. In fact, carbon 3 has 2 methyl branches. That's why it says 3,3-dimethyl octane. So go to the third carbon. It doesn't matter from which end you count. You can count from the left or count from the right. I'll go from the right. So this would be carbon 3 with 1 methyl branch and another methyl branch. All right, so there's 3,3-dimethyl octane. Its chemical formula with 8 carbons would be in octane, and then 2 more carbons in the methyl branches, so C10, and then H 2 times that plus 2 gives me 22, C10H22. Now remember, when you look at a bond line formula, you have to understand that the carbons and hydrogens are understood to be there because they're not shown in the diagram. So at every vertex, there is a carbon atom. That's what you should imagine. And then the number of hydrogen atoms is to give each carbon a total of 4 bonds. So if you're an end carbon, you have only 1 bond, you'll get 3 hydrogens. The next carbon, counting from the right, has 2 bonds right now, so it gets 2 hydrogens. The carbon up above on the methyl branch gets 3 hydrogens. Again, we're trying to give the carbons 4 bonds total. The methyl down below has 3 hydrogens. The carbon in between those methyl branches has 4 bonds already, so it does not get any hydrogen atoms. The carbon next has 2 bonds, so we'll give it 2 hydrogens. We'll give 2 hydrogens, 2 hydrogens, again, to give each carbon a total of 4 bonds. And the last carbon has 1 bond, so we'll give it 3 hydrogens. Whether you write it as H3C or you put CH3 doesn't really matter. So that's what you should imagine when you saw the bond line formula. All right, I think that's the last one I'm going to do with you. For homework this weekend, if you could try completing up to question 15C. Okay, so in your homework this weekend, do up to question 15, part C. We'll start on Monday with question D together, and we'll look at some of the answers together. All right, so I hope that helped.